All right, let's take a look at one more example of solving linear inequalities. What is different about this one? Well, let's take a look. Okay, so the first thing I need to do is decide on the bottom whether I'm going to have a solid boundary, which is going to be this right here, or a dashed, which is this one, right? Which one? All right, how do I know that? Well, I need to look at the sign. So I look at this sign right here. If it's less or more, that means the boundary is not included, so it should be dashed. If it's less than or equal to or greater than or equal to, that means the boundary is included, so it will be solid. Well, for me, it's not included, so I am going to click over here. So I just selected the one that's dashed. So next thing I do is I pretend that that sign more than is just equal. So I need to graph the boundary. And the boundary is y equals negative 4x. Well, how can I graph that? Okay, well, it's actually not hard. We need to know the point, right? Or the y-intercept, let's say. So the y-intercept happens when x equals 0. So y-intercept is when x equals 0. But when x equals 0, negative 4 times 0 is 0, right? Because any number times 0 is 0. And then we're just going to get y equals 0. So what happens is your y-intercept is just 0, 0. And then the slope, well, the slope is given by the number in front of x, which is negative 4. Which means, so remember, the slope is going to be rise over run. But what is over? Well, I'm just going to say divide by 1, because you can always divide by 1, right? And that's not going to change the number. So then this is going to be your rise. And then this is going to be your run. And the rise is really not rise. It's actually fall, right? So, okay, let's take a look. So we're going to go 0, 0. So we're going to start over here. And then we're going to go, well, 4 down, 1, 2, 3, 4, and 1 to the right. And that's where we're going to wind up. Okay, so that's going to be our line. All right, so let me graph that. So 0, 0, I picked that. And then also there's going to be 1 to the right and 4 down. Okay, so I think I'm good right here. And now I have to decide, do I shade the right side or the left side? Well, this is why this example is different, because normally I pick a test point that is 0, 0, because that's the easiest point to pick. But I can't do that here. Why not? Well, 0, 0 is actually right here, but that is on the boundary. So I can't pick a test point that belongs to the boundary, okay? Can't do that. You have to pick some other one. So I will pick 1, 1. Now, which one doesn't matter as long as it's not on the boundary. Okay, so I'm going to pick a point 1, 1. And if I plug it in the inequality and it is true, then I will shade the part that contains that point. So I will shade it to the right of this line, dash line. But if it was false, if it becomes false, then I would shade the left part because it shouldn't be there. Okay, so let's plug it in. So for y, we are plugging in 1. And for x, we're also plugging in 1. So we're going to get negative 4 multiplied by 1. So this means 1 greater, negative 4 multiplied by 1 is negative 4. So if 1 is 1 greater than negative 4, well, yes, any positive number is more than any negative number. So yes, this is true. So that means that the region that we shade should contain that 0.11 because that's when the inequality was true. So we're going to shade to the right of that line. Well, let's check this out.